Okay, I've got a graph here and I'm going to do some gradients. Okay, so I've got a graph, it's a cooling curve. On the y-axis I've got temperature. Okay, I've got to put my units on there, otherwise it doesn't mean anything at all. It's temperature degrees Celsius, and on the x-axis I've got time, and I've got time in minutes. Okay, this is a cooling curve for a substance that's changed state. It's gone from liquid to solid. Okay, and it's solidified in this region here, where the gradient has the rate of cooling has decreased to almost zero, but not quite. So I guess it's not a very pure substance. And we can see that we've got an initial cooling stage where the gradient is relatively steep, freezing stage where the gradient is almost zero, and then it starts to cool again. The temperature decreases, but not at quite the same rate as it did initially. Okay, so we've got initial cooling, freezing stage, and a final cooling stage. I'm interested in the gradients of those curves. Okay, gradient of a graph is given by, let's use a pen so it shows up. Okay, gradient of a curve is given by the change in the y value. Okay, let's just move that down a minute, divided by the change in the x value. In this instance, my change in y is going to give me a change in temperature divided by the change in x value, which in this case is minutes in time. So I've got my gradient tells me a change in temperature per minute, or per time in minutes. Effectively, my gradient is rate of cooling, okay, in degrees Celsius per minute. Okay, that's really what my gradient is telling me. Delta y over delta x. Okay, I'm going to substitute in my labels. I've got temperature divided by time. I'm getting degrees Celsius per minute. It's a rate of cooling. Alright, so I'm going to calculate my rate of cooling in 3 places. I need to use a pencil here in case I mess up. Okay, sometimes I'll use a pen just to sort of highlight things so you can see it more clearly. Now we've got a curve here. Gradient of a curve, I need a straight line really, so I'm going to draw a tangent, and I'm going to draw a tangent at one point of this line. I'm interested in where the rate of cooling is quite high, so I'm going to draw a tangent near the beginning of my investigation. Okay, I'm going to draw a nice long line. I can make that as long as I like. Okay, I'm going to choose a point where I'm going to measure my change in x, and then I'm going to calculate the change in y for that change in x, and I will get a rate of cooling for this line. So I'm going to choose 30 degrees, just because it's on my scale. It's a nice round number. You can choose where you're going to start. I'm going to draw a line across there. Okay, so for a change in x at that position here, I've got a change in y. Okay, from where my diagonal line intersects the axis there to this temperature here. So let's just get my change in x to start with. My change in x, my change in temperature, in time rather, is from 15.5, I'd say, to 0. So I'm going to, for the difference is 15.5 minus 0, that gives me 15.5 minutes. In 15.5 minutes, at that gradient, my temperature change would be from this point up here to this point here. The difference between this temperature and this temperature is 75 minus 30. My change in my y value is 45, and that's degrees Celsius. Okay, so I can calculate. Let's do this on pen so you can see it a bit more clearly. Okay, my rate of cooling for this first gradient is 45 degrees divided by 15.5 degrees, which gives me a value of 45 divided by 15.5, 2.9. 2.9 degrees Celsius per minute. Okay, that's my rate of cooling for my first initial cooling stage. Okay, just to make that really clear. Obviously you can put this in the text of your report. I'm going to underline my answer. Okay, and I guess I should just call this my initial rate of cooling. Okay, I'm very interested in the freezing stage gradient. It's a very shallow gradient. Once again, I'm going to choose where I draw my gradient, and I'm going to go with that bit there. It's not a very smooth line of best fit. I've got to be careful. I'm going to choose the gradient. I'm going to draw a line like this. I'm going to do a nice long line because I haven't got very much change in y unless I've got a very large change in x here. Okay, so I'm going to try and make that quite long. It gets a little bit tricky. I'm going to go from 55 minutes, so it hits the line there. I'm going to draw a horizontal line across. Okay, make sure it is actually horizontal, it's following the lines. Okay, you can calculate the gradient wherever you like. I'm going to get to that point now. You're making a right angle triangle. You just want a change in y, okay, and a change in x for that slope there. So we've got a nice right angle triangle here. So my change in x for that triangle is going from 10 minutes up to 55 minutes. So for my freezing stage, where can I write that? I'll write it here. My freezing stage rate of cooling is going to equal my change in the y value for that triangle, which is 51 to 43. 51, the difference between 51 degrees and 43 degrees gives me 8 degrees Celsius divided by my change in x, and I'm going from let's say 56 seconds, minutes rather, 56 minutes and 10 minutes. My change in x is 46 minutes, which gives me a final rate of cooling of 8 divided by 46. 8 divided by 46. It's very low, 0.17. 0.17 degrees Celsius, okay, per minute. Okay. I automatically went into writing out my delta y. I hadn't actually really solved that in there, but you know, you can see what I've done there. I'm going from 51 to 43 degrees, so that's 8 minutes. Okay, that's my delta y. I'm going to divide that by my change in minutes. 56 minus 10, so that's 46, and I put that in down here. Okay, so my freezing, at the freezing stage, my rate of cooling is only 0.17. Okay, which is a lot less than it was before. Nearly 3 minutes, nearly 3 degrees Celsius per minute. Now I've got less than 0.2 degrees Celsius per minute. Now the final gradient, okay, it's not as steep as it was before. but it's certainly steeper than the freezing stage. I'm going to do another gradient there. You can draw your line wherever you like. Okay, I've got text all over my graph. You need to put this text in your report anyway. You don't have to draw it on the graph. It might be better than not to be honest, because it gets quite busy and I am kind of spoiling the graph. So you can obviously do these calculations elsewhere, not on the graph. It's entirely up to you. If you plan it better than I have, you can probably do it quite neatly. Okay, so I've selected my tangent for my final rate of cooling, which is there. I've got a change in x, and I've got a change in y. I've got a change in minutes, and I've got a change in degrees Celsius. So for my final, I'm going to write it up here. For my final cooling stage, okay, my final cooling rate equals my change in y. Let's do a change in y first. I've got 10 degrees. I've got 48 degrees. So my change in y for that one is 48 minus 10 equals 38 degrees C. Okay. Divided by my change in x, which is let's call it 54.5 minutes. I'm going to say 50. I'm going to round it up so you can be more precise than me. I've got 55 minus the 20, so we're talking about 35 minutes. Okay, 38 divided by 35. .08. That's going to just round up to 1.09 really. Okay, and that's going to be degrees Celsius per minute. I'm going to rewrite that because it's a bit cramped up there. So my final cooling rate equals 1.09 degrees Celsius per minute. Okay, we can check that's a sensible number because we can see that I've got for 3 gradients. I've got the steepest one is here, that should be the largest number, and I've got just shy of 3 degrees per minute. I've got a very shallow one there which should be quite close to 0, and I've got 0.17, and I've got a steeper gradient again, but not as steep as before, 1.09 degrees Celsius. 3 gradients. Put these calculations in the text. Okay, you can see how busy the graph gets, so if you show you're working on the graph, be prepared to mess it up and have to do it again. I wouldn't really want to hand this mess in. Okay, I'd want to do a final version where I've laid it out neatly. I think putting the calculations in the text is best. You could maybe just do show that you do need to show the tangents, and maybe you can just show the change in x and the change in y values, and put the actual calculations in your report rather than all over the graph like I have. But hopefully you'll now be able to do your gradients. Alright, draw your tangent, turn it into a right angle triangle. You're going to draw your horizontal x sort of line and your vertical y line. You've got to work out the differences. Okay, differences in y and the differences in x for the triangle that you draw. Okay, I haven't used genuine data here, so your numbers are going to be different to mine, so don't copy mine for goodness sake. Okay.